Let's look at summation examples. These are based on 3 sequences from another sequence video that I just did. So the first one is a sub n is 19 minus 4n. It's arithmetic. That's crucial when you have a linear function of n. That's an arithmetic sequence. Here's the first 5 terms, dot, dot, dot. Okay. And I want to sum the first 150 terms of a sub n, for example. Okay. So we know that the formula for a sum of an arithmetic sequence, only for arithmetic sequences does this formula work. Well, that's the only case that we know it works for. It's you take the average of the first and last. Ooh, I don't know the last term yet. What is the last term if I have 150 terms? Well, that's going to be something we need to figure out. But then there's a question mark. So this is our quick and dirty way of getting the average of all 150 of the first 150 terms. You average the first and the last of the 150, and then you multiply by how many terms there are. That's the way I like to explain that formula. Okay, but oh gosh, we need to know what A150. Okay, well, we can go ahead and just plug in. Oh yeah, it's right here. We can just plug that into the formula we already have. So that's one reason you'd want the master formula, is it easily gives you what that last term is if you're going to do a summation. Otherwise, we would have had to do a lot of guess and check, maybe. Okay, so that's 19 minus 4 times 150, or 19 minus 600, or minus 581. Okay, so the sum, oh, and let's write that out. How about I write that as sigma notation, because it's good to be comfortable with that. That's the sum, n equals 1 to 150. That starts with the first term, then goes up to the 150th term, that's the correct sum, of 19 minus 4n. Okay, and because this is arithmetic, we can use our shortcut formula. 150 times 15 minus 581 over 2. Now, I should have done this actually before. What kind of answer should I get for this? Notice the first 4 terms are positive, but then there's a negative, and if I keep going, almost everything else after this is going to be negative. And I've got a lot more negative terms than positive terms that are adding up. So I should get a pretty big negative answer, and that's what's going on here. That 15 plus has turned into 15 minus 581, and that's entirely appropriate because we're adding really mostly negative numbers there. And if you calculate that out, it turns out to be minus 42,450. Whoop, 450. Okay, so that's a simple example of summing up an arithmetic sequence. Let's do another one with a slightly different pose, a different way to pose it. Let's just say suppose they gave you 15 plus 11 plus 7 plus 3 plus minus 1 plus, and then it ended with a minus 401. Or in other words, a plus a negative 401. Okay, well first, is that really in the same pattern? That's a multiple of 4 minus 1. That's a multiple of 4 minus 1. That's a multiple of 4 minus 1. That's certainly a multiple of 4 minus 1. It's 0 minus 1. That is minus 400 and then minus a 1. So it really does seem to check. They're not trying to cheat and say and change up the pattern in the middle of the dot dot dots. Okay, so I just need to find the sum. Well, again, the sum is first plus last. Oh, okay, I know that now. Over 2. That's our quick way to find the average of all the terms without having to average every single one because they're this nice uniform pattern. But now I don't know n. Okay, so here I need to actually find n. But again, I have the master formula. Now, if somebody just gave you this problem without previously knowing the master formula, this is where you're going to have to take a detour and find that master formula. That's really probably the most efficient way to actually find n. So here's a situation where we know the nth term, but we don't know the mystery n, but I can solve for n. Okay, so I subtract that over, I get minus 420 minus 4n, n is 105. So it's the 105th term. And that makes sense with what we had before. In the previous example, the 150th term was a significantly more negative number. Okay. So now finally the sum is going to be 105, and then this is going to be minus 386 over 2, and that's 105 times minus 193, which is, not that it's the most crucial thing, but let's just 105 times minus 193. might as well get an answer. Minus 20, 2065, minus 20, 265. And that's not nearly as negative a number as we got before because we didn't go as far into the negatives on that sequence. Okay, so, and if we wanted to write this as a summation using the fancy sigma notation, what would this be? Well, that's another place where we really kind of need to do this calculation. It's the sum n equals 1 to 105, that's the last value of n we put in, of 19 minus 4n. Okay, so that's another thing. Even if I just asked you, take this guy and just package it up as a summation. Don't even evaluate it. Now, I'd probably want you to evaluate it too, because we know how. That, again, you have this crucial thing of get that master formula and plug it in. Okay. One general thing, I want to focus mostly on examples here, but just remember the general formula for an arithmetic sequence is a sub n is that a sub 1 plus n minus 1 times d. Just want to focus on the fact that and I've talked about this in class, that this relates four interesting quantities. The first, the last, the common difference, and what index the last carries, which one in the sequence it is, or how many terms in the sequence are you considering. Usually in a problem, you're going to be given 3 out of the 4. And you have to use this equation some way or another to solve for the fourth, but it can always be used to solve for that fourth piece of data. So if it's even a slightly unfamiliar problem, focus on that. Okay. I'm going to do another video on summations, but I want to break it up into small ones, so I'll stop here.